Hi, I'm Anna Newman, and this is my reaction timer project. For this project, I will use the D0 board to make a reaction timer. A button will be pushed, one of the push buttons, and then after some random amount of time, a green LED light will turn on, and then I must push the button as fast as possible, and the 7-segment display will show the reaction time. The D0 board has a 50 megahertz clock in it, but for the reaction timer, we're going to use a 100 hertz clock. So to do this, we need to make a clock divider. So what a clock divider does is basically it's going to count a positive edge of the clock from the D0 board, every positive edge, so many times, and then make the new clock switch back and forth. So for our example, is our D0 board has a 50 megahertz clock. So half of 50 megahertz is 250,000 hertz. So basically, the clock is going to count 200, or a counter inside clock divider is going to count 250,000 times, and then tell the new clock to go high or low, depending, like if it's already low, tell it to go high, and if it's high, to go low. And we do that because 250,000 is half of 50 megahertz. So as you can see in the picture, 250,000, the counting that many times, is going to be half the period for our new clock, and then counting it 50,000 times will be a full period for a new clock, which will now be 100 hertz. So this is my clock divider Verilog code. You can see the count and keeps increasing until it hits 250,000, and then clock out equals not clock out, so that changes it from high to low. And yeah. For the parameters, clock in is the 50 megahertz clock, and clock out is the 100 hertz clock. So the rest of my code works with states, and so this is my state diagram. The first state does nothing and resets basically everything back to 0, and then so the button is pushed on the D0 board, and then which makes it go to the second state, which is the delay function. And once the delay function is done, so the delay function includes the LFSR, which I'll explain later. And so once that's done, it triggers the third state, which turns on the LED light and the BCD counter. And so then you push a button, then you push another button, which takes you to the fourth state, which stops everything and displays the reaction time on the screen. And then you push a button again to go back to the first state. So that's like the line at the bottom of the picture, which resets everything back to 0. So as the beginning of my code, line 23, you can see the clock divider, and everything else is basically just initializing everything. So this is state 0, which basically is just waiting for the button to be pushed, and if something's already been going on, it resets it to 0. And then state 1, if button 2 equals 0, that means it's pushed, and then state 2 will start to happen. So the registers underneath each state, they're either 0 or 1s, and then the 1s enable the modules down below. So for each state, different modules will be enabled. So we have BCD counter, and then LFSR, and a segment, which is 7-segment display, and then a delay. So state 0 has everything off or on reset, and then once you push the button, it moves on to the next state, which turns on the enable for delay cruising. So before I can talk about my delay module, I have to talk about the linear feedback shift register, which this is going to generate random numbers, which it's not totally random. It's actually following a pattern, but basically the output from here, it is a random number that's going to be put into the delay module. So here is my delay, which is the random amount of time before the green LED light is going to turn on. So basically, it's just going to take a number from the LFSR, and then I'm going to count that many times until it reaches that number, and then if you can see the variable X, well, the register, the output register, I make it turn 1, and once that 1 happens, it moves on to the next state. So here's a histogram of the random delays, like time of delays. So basically, there's a random delay. So the bottom numbers are like how many seconds. So out of 20 tries, I should have put that on there. I thought I did. Out of 20 tries, it was 1 second 3 times. it was 2 seconds 6 times. It was 3 seconds 7 times. It was 4 seconds 2 times, and it was 5 seconds 1 time, and it went up to 6 seconds. And I think it's even gone more. I don't really know the exact pattern it goes, and these are kind of rough estimates, but I'm sure it went up to 7. So here's the next state, which is turning on the LED, and it's also turning on the BCD counter and the 7-segment display, which displays the BCD counter. So this is the BCD counter, and it's basically the same one in the book, but I added a 3rd digit, and it's basically just keeps counting. Well, at least in the 2nd stage, it keeps counting until you push the button, and then in the 3rd stage, it will stop. In the last stage, it's going to stop counting. So then this is just my 7-segment display, which takes the BCD numbers and outputs them on the 7-segment display on the D0 board. So now you push the button as soon as possible after you see the LED light. So this would be your 2nd time pushing the button, and everything stops. But it doesn't reset anything. It just keeps the 7-segment display lit, and then basically it's just waiting for the reset button. So then you just push the button again, and it will take it back to the 1st stage, and where everything is reset to 0. So that's all my code, and this is just the pin planner where I set all of the LEDs up and set up just all the buttons and everything. So here's the D0 board, the reaction timer working. What you want to pay attention to is the very leftmost LED. I was debugging with the other 2 LEDs. It was telling me what stage I was in, and I forgot to take those out. But basically, I pushed the very leftmost button, so right here, and I'm waiting for the leftmost LED turns on, press the right button. That's just how I programmed it. And then the middle button resets it. All right. Here's Jill. So these are just 2 of my friends playing with it, showing you that anyone can use this. Yep. Thank you for watching.
Okay, Mandy. Okay. I'm failing.
Oh, I can't swear.